Digital visualization is the use of computer graphics and animation to create representations of objects, situations, or sets of information as charts or other images. Visualizations can be three-dimensional or two-dimensional. Three-dimensional images have or appear to have length, breadth, and depth. Two-dimensional images have or appear to have length and breadth, but no depth. We'll be using a variety of tools to create images, principally a program by Autodesk called Maya for three-dimensional or 3D work. And when we work on our two-dimensional projects, we'll be using software from Adobe. The software from Adobe we'll be using is called Illustrator, Photoshop, and Animate. So that's three different programs: Illustrator, Photoshop, and Animate. We'll use other programs besides those that I've listed, but these are the main ones. Vocabulary is an important part of learning digital visualization. It allows us to communicate about what we're doing. You may be familiar with much of our vocabulary already thanks to your math classes. For example, we create images from polygons, which you may already know are straight-sided shapes. Polygons must have three or more sides, defined by points called vertices, and the straight lines that connect those points we simply call edges. The interior region of a polygon is called the face. Vertices, edges, and faces are the basic components of polygons. The locations of vertices are defined using a Cartesian coordinate system. A Cartesian coordinate system specifies each point uniquely in a plane by a pair of numerical coordinates, which are the assigned distances from the point from two fixed perpendicular directed lines measured in the same unit of length. You should be familiar with Cartesian coordinates from your algebra and geometry classes. You are probably used to two-dimensional systems based around planes with an x and y axis. When we work in three dimensions, a z-axis is added for depth. We create three-dimensional models by piecing together polygons. A cube model, for example, is created by piecing together 6 polygons. The number of polygons used to make a model is known as the model's polygon count. The higher a model's polygon count, the larger the file size when the model is saved. Computer monitors can obviously only render in two-dimensional images, so in order to analyze three-dimensional images displayed on your monitor, we need to look at images from a variety of angles. The angles we look at models from on our screens are called orthographic views. Orthographic views are two-dimensional views of three-dimensional objects. Orthographic views represent the exact shape of an object as seen from one side at a time as you are looking perpendicularly to it. Depth is not shown. There are 6 orthographic views, just as there are 6 sides of a cube: top, bottom, left, right, front, and back.